Hey guys, welcome back. In this Blender video, we're going to model this angle valve casting shape. This is a really great shape to practice because it has multiple cylinders intersecting and connecting together, and we'll go step by step to handle those connections cleanly. You'll find this kind of shape in a lot of real-world objects like water taps, microphone stand joints, shower faucet valve bodies, automotive parts, air pressure regulators, and many more. So once you understand this workflow, whenever you run into a similar shape while modeling, you'll already know how to approach it and build it with clean, controlled geometry. All right, so with that out of the way, let's get started. First, we'll start with a sphere. But if we use the default sphere here, it won't give us clean quad geometry, and the topology won't be ideal for this kind of shape. So we're not going to use this one. Instead, we'll use a cube. Then we can use a subdivision modifier to smooth it and turn it into a sphere. And after that, we may use a cast modifier to make it perfectly round. But for this, we don't need to go through all those steps. There's a better option, which is the rounded cube. You can find it right here. This works similar to subdividing a cube into a sphere, and here we get much quicker control, and in the corner panel, we can adjust the segments and other settings as well. So here, set the vertices to 6. This keeps the sphere at 24 vertices, which we need. And you can see that at the bottom. The reason we're using 6 is because in the reference, we have a hexagon-shaped nut, which has 6 sides, so this will make it easier for us to connect the geometry later. So always choose your vertex count based on what you need at that moment by analyzing and planning before you start modeling. To use that rounded cube, you'll need to enable the Extra Mesh Objects add-on in the Preferences under the Add-ons tab. If you don't see it there, you can also find and download it from the Extensions tab. It's free and comes with Blender. Now, we'll model the side cylindrical joining ports. So the first idea you might think is select this area of faces, inset it inward, then use Loop Tool's circle to make it circular. Then here, uncheck flatten so it stays nicely curved with the sphere and then extrude it out. But with this method, we cannot properly control the circle size. One way we can try is to check this radius and then adjust the size of the circle. But even with this, it only works inside that boundary. If we go outside the boundary, the circle breaks and gets distorted. And if we want to place a cylinder somewhere in the middle of an edge loop, we cannot do it cleanly and precisely. So we're not going to use that method. Instead, we'll use a Boolean to join the cylinder so we can do it cleanly and precisely. So for that, first add a cylinder. Then here, change the vertices to 24 so it matches the sphere and everything lines up properly for the Boolean. Now, scale the cylinder, move it, and place it nicely, looking at the reference so it matches the reference exactly for the Boolean cut. Now, duplicate the cylinder, then move it down for the bottom outlet. Here also, fit it and place it nicely, lining everything up. At the bottom, it is slightly smaller, so scale it down accordingly. Now we'll add the side cylinder outlet, but if you notice, the side cylinder is slightly smaller and the vertex count will also change. So to check the vertex count, select the faces where the cylinder will go, inset it inwards, then delete the faces, then select this full edge loop, and at the bottom you can see how many vertices we need. So we need 16, so undo this. Now add a cylinder, then here change the vertices to 16, then rotate it, scale it, move it, and place it nicely, fitting it properly in position for the Boolean cut. Fine-tune all the cylinders nicely before applying the Boolean. Once everything is fine, we'll add the Boolean, but using the Bool tool add-on. First, select all the side cylinders, then select the main sphere mesh. Press Ctrl-Shift-B for Bool tool panel and choose Union. This will merge all the meshes. Make sure Bool tool is enabled in Preferences. Then we'll apply all the Booleans. This cutter object we don't need anymore, so hide it or delete the Boolean cutter objects. Now it's properly joined, so let's clean this up. First, select the full mesh, then press M and merge by distance to remove overlapping vertices. Now we'll clean up these floating vertices. So first, turn on auto merge at the top. Now slide these vertices into place and they will automatically merge when they touch. To merge these vertices quickly, box select all of them first, then select the last vertex you want to keep as the target. Then press M and choose Merge at last. This will quickly merge all vertices at the last point. Here, select and join these vertices. Rest of the floating vertices, just select and merge them, same way we did before, by sliding and merging until everything is clean. We'll only do this on one side. The other side will be mirrored. Now with the knife tool, add a cut like this all around here to redirect the edge flow, then dissolve these two unnecessary edges. Over here also dissolve, and now here it's fixed and we get nice clean geometry. Now slide and merge these vertices of this cylinder part and repeat the same steps how we did for the previous cylinder to fix this. Here with the knife tool, add a cut all around. Then merge and fix this nicely. When we slide to merge here, because of the cut, the edges won't move across the full mesh. They'll move only up to that point within that cut area, which you can see when we slide. Now that this part is fixed, let's move to the bottom cylinder. And here, fix it the same way we did previously. Repeat the same steps. All right, so now we've fixed and cleaned up all the Booleans. So let's move to the next step. All right, now let's work on this top part. So select this top face, then move it down a bit and position it nicely according to the reference. Then extrude this up just a little. Now here, add a loop cut where we can see that separation. Then press V to rip the mesh. This will tear and separate the mesh. After that, scale this inward a little. Then press Ctrl L to select this full top mesh, and press P, separate by selection, to make it a separate object. Now select this inner full edge loop and extrude it up a bit. Now go into the separated mesh, the one we separated before. Select this face and inset it inward. Stop till where the nut will sit. Then delete the middle face. Now select this edge loop, press Shift S, cursor to selected. This will place the 3D cursor at the center. Then add a circle, and then here change the vertices to 6 so we get that hexagon nut shape. Now scale it down, bring it inside this area, and position it nicely. Next, we need to connect this circle with the mesh. So for that, we have to subdivide it to match the same vertices. So subdivide this until we get 24 vertices on this edge loop. You can see the count at the bottom. Then extrude it up a little, and then extrude it up again a bit more. Now scale it inward. Then use Loop Tool's circle to make it perfectly circular, and make sure the Loop Tool settings are set to default, which we had tweaked earlier, so now this stays clean and flat. Now here, this part is slightly curved, so to achieve that curve, what we can do is, I'll show you a different way. First, select this edge and dissolve it, then add a loop cut here. Before confirming, press E to align it evenly to one side, and press F to flip it in case it follows the wrong side. Here, we want it aligned with the bottom side, which it does. Now to place it properly, go over here, change snapping to vertex, and enable active, and also scaling. Now make this vertex active, then scale this, press Shift Z so it scales only in X and Y, and hold Ctrl to snap it to the outer vertex, and now it sits properly. Now to add the curve, scale this in the Z-axis, and you can see we can curve this easily how much we want. When we scale, it curves because the edge was already slightly curved. If the edge was flat, it wouldn't work. Now just adjust this part, tweak it to get everything right. Select this edge and extrude it inward. Now we will curve this part. So to do that perfectly, first, select and delete these faces. Then select both of these edge loops and then use bridge edge loops. Here, adjust the number of cuts, keep it nice and even so it curves properly, set interpolation to linear, and profile shape to inverse square. Now adjust the profile factor and you can shape the curve nicely. After that, select all these edge loops and use Loop Tool Circle so they stay circular and flat. Now to connect this with the other mesh, select both edge loops and use bridge edge loops. Here, you can see it's not connecting properly, so what could be the reason? Go over here, turn on face orientation. You can see this top part is red, so the normals are flipped. So select the full mesh, press Shift-N to recalculate normals. Now select those edges again and use bridge edge loops, and now it connects properly, clean and nice. Now select this edge and dissolve it. No, don't dissolve it, just slide it and place it nicely. Then select these faces and press Alt-E, extrude along manifold, just extrude it up a little. Delete these interfaces that were created. All right, now let's bevel these sharp edges, so select all of them, and after that, bevel them. Set the profile shape to 1 and turn off loop slide. Now add a solidify modifier to give it some thickness. Apply scale first, so there are no issues. Then adjust the thickness value. Okay, this looks good. Now add a subdivision modifier. Then also shade smooth the object. Here, this edge also needs to stay sharp, so bevel it a little to keep it sharp. Now select these vertices and merge them like this. Then dissolve this middle edge. Now this part looks fine. At the bottom, dissolve these edges. Now to fix this part, do something like this. Now this is fine here. Just space these vertices nicely. And this is good now. Now select this full edge loop and bevel it. Then add a loop cut here to keep it tight. Now this part looks sharp and it looks good. We don't want to repeat these steps we made to keep this sharp on all sides. So to speed things up, go to top view, select these side parts and delete them. Keep only the part we edited. Select that part, press Alt-E and choose spin, enable use duplicate, then set the number of copies. After that, select the full mesh, press M, merge by distance to merge everything, and now it's clean. Add a loop cut on this border to keep it sharp. Add one here as well. Now this top part is done. Let's move to the bottom side. Now, at the bottom, select this face and delete it. Select this edge, move it upward, and position it properly. Shift-S, cursor to selected, place the 3D cursor at the center of that point. Now, add a circle. This will be for the hexagon nut shape. See that vertices are set to 6. Scale it and position it nicely. Now subdivide it, for getting 24 vertices on this circle to connect with the other mesh. Then select this edge and extrude it downward. After that, select both edges, use bridge edge loops. This will fill the gap. Adjust this a little to get it nicely. Now at the bottom, extrude scale it inward, then use Loop Tool's circle to make it perfectly circular. Alright, so this bottom part is done. So now let's move to the side part. Select this face on the side, then move it inward and position it nicely. Then delete the face. Now we will create the threads here, which you can see in the reference. So to do that, first select this vertex. Then duplicate it and separate it by selection. Then select that separated vertex. Make sure you apply scale first so it behaves properly. Then extrude it forward. Extrude it about 0.1 units. We'll see why we use that distance in a moment. Now add a screw modifier. Make sure over here you select the correct axis so the screw works properly. Now adjust the screw value to move it forward. Type 0.1 here, so it moves further and merges at the right point. That's the reason we extruded 0.1 units earlier, so we can move this forward the same distance and it merges. Now set the number of iterations. Looking at the image, it looks like there are around 6 to 7 threads, so let's set it to 6 iterations. Now, to make this look like a screw, we need to shape this part. Add 2 vertices on this edge, then select the middle edge, extrude it upward a little. Select this edge, scale it sideways to widen it slightly. Then delete this inner edge. See that the edge is shaped something like this? Tweak it a little to get it right, and this looks good. Now, when we activate the screw modifier, it will form the screw threads clearly, which you can see here. Now we need to fix this mesh, and also this looks a bit too big. So first apply the screw modifier so we can fix this. Now select the full mesh, then scale it on the x-axis to make it smaller. Alright, this looks good. Now with the full mesh selected, press M, then choose by distance to merge overlapping vertices. Now to fix this sideways mesh over here, what we can do is select this full outer loop only, then deselect these edges over here. Then extrude this out, and then press SX0 to flatten this. Then move it back and place it into position. Select these edges over here like this, then press F to fill this gap. Select and fill this gap too. Then select this edge and slide it slightly back. On the other side also, make sure you do the same thing we did on this side. Dissolve this full edge loop all around over here. Now over here we will clean this geometry and remove that n-gon, and we'll see how we can get clean quad geometry. So here I'll show you a few different ways to fix this part. One way is to connect the vertices like this on both sides, then add a cut in the middle. Scale this in, and we get all quad geometry. Another way we can do this is select and join these vertices directly here. Then with the knife tool, add a cutout like this here, and we get that quad geometry. You can also do the same thing, flip the other way around. Another way is to connect vertices like this here, and we get all quads here. One more way is to connect vertices like this on both sides, then add loop cuts like this on both sides, and here we get that result. For this, we'll go with the first way, which I showed you. You can use any of the ways I showed, or there could be more ways too, which you can try and use. But the main thing is to keep this clean quad geometry and make sure there are no artifacts or pinching. Now extrude this edge out so that this part doesn't remain on the border. Make sure you do the same thing we did on the opposite side and fix that there. Now add a subdivision modifier. And now this is good. Now we have to connect and join this with the main mesh. So first select the thread mesh, then select the main mesh, press Ctrl J to join. Then press Ctrl L and select this full thread mesh. Make this side vertex active, then move this back and snap it here while holding Control. It will merge due to auto merge. Now we will give this some thickness, so add a solidify modifier. Make sure you first apply scale, then adjust the thickness value. Okay, so here the thickness looks fine. So now let's straight away apply the modifier. Make sure you enable even thickness, then apply the modifier. Now here, we don't want these threads on the inner side. So select all the faces where the threads are present. Make sure you select that full area properly. Once selected, delete that full part. Then select both these edges here, and then use bridge edge loops to fill this. On the other side, we had not cleaned the Boolean because we were going to use the mirror modifier. So let's add a mirror modifier to mirror this on the other side. Make sure you add the mirror and apply it earlier beforehand, so there are no problems later on, which we didn't do in this case. Then let's apply the mirror modifier. Make sure clipping is enabled, then apply it. Select these inner faces here, scale this up slightly to increase the thickness. Select these outer edges, bevel them to keep them sharp. Dissolve this inner edge loop, then add 2 loop cuts here. Now select this edge. After that, bevel this edge too. On the inner side, see that you bevel it too. Here this edge loop is not flat, as you can see, so select it. On the inner side, make sure you select this edge as well. After that, press SZ0 to flatten it, then bevel it to keep it sharp. Select these edges over here. Select all these edges here. After that, bevel them. At the bottom, also select this edge. On the inner side, see that you select it too. After that, press SZ0 to flatten it, then bevel it. Select all these sharp edges over here. After that, bevel them. add a loop cut over here. Now let's add a subdivision modifier. After that, shade smooth the object. Okay, so over here, this part has to be sharp. So first dissolve these beveled edges. Now select all these sharp edges like this all around. After that, bevel them. On the inner side, see that you bevel it too, the same way we did on the outer side. Okay, so now this is done. Okay, so over here, when we use this shiny matcap, you can see everything looks really nice and smooth, and it just feels right. So overall, the model is looking really clean and nicely shaped here. Okay, so over here, after applying the mirror modifier, our screw threads also got mirrored and they got destroyed, as you can see. So make sure you apply the mirror before doing the threads, right after finishing the Boolean cleanup, so this problem doesn't happen. And one more thing, always remember before applying any modifier, keep a copy of the mesh so you have a backup. Good thing is I already have a copy, so now we can connect it back with the mesh. So to connect this, select the faces in this area where the threads are present. After that, delete them. Now bring back the duplicated copy of the threads. Join it with the main mesh, then select the full thread mesh, move it back and snap it into place. And it will snap automatically since auto merge is turned on. And now this looks good and it's done. All right, so we are done modeling this nicely, and I hope you learned something from it. So if you found this video helpful, don't forget to like, share, and subscribe, and also comment below and let me know your feedback. So thanks for watching, and I'll see you in the next one.